Hello everyone, hope you're doing well today. Let's go ahead and practice our double displacement skills, specifically predicting the products of these double displacement reactions that involve the production of gases. So in the previous video, we talked about the rules that govern those kinds of reactions, what intermediates are formed if you have particular reactants, what intermediates are unstable that break down to give you a gas. So let's try those, remembering those rules and our double displacement reaction skills and predicting the products and giving balanced chemical molecular equations for these four examples. In this first one, I have sodium carbonate, aqueous, reacting with sulfuric acid. And then in predicting the products, let me get my little pen here again. In predicting the products, I'm going to do my little crisscross, and I see that my cation is sodium, my anion is carbonate, my cation for the sulfuric acid is H+, my anion is sulfate, SO4 -2. And so doing a quick crisscross, cation of one pairing with the anion of the other, I see that I'm going to get sodium with the sulfate to give me Na subscript 2 SO4 because sodium's a +1, sulfate's a -2. Sodium sulfate, which my solubility rules tell me is aqueous, and H2CO3, carbonic acid. And when I see that carbonic acid, I remember, oh, those rules when predicting double displacement reactions. If carbonic acid is formed, that is an unstable intermediate, which breaks down to give CO2 and water. So the final products of this reaction is still the sodium sulfate, that's aqueous, carbon dioxide, gaseous, and liquid water. That comes from the unstable intermediate H2CO3. Let's do something similar with this next example. And so in this next example, we're still going to do the little crisscross to predict our products. I see that the NH4 is going to be paired with the OH and the Li with the ClO4. Doing that, I get ammonium hydroxide and LiClO4, lithium perchlorate. When I see that NH4OH, I remember from the rules of unstable intermediates in the previous video, that's going to further break down to give me NH3 gas, ammonia gas, and liquid water, along with the lithium perchlorate. So what you see in bold here on the right, those are the products of this balanced chemical equation. We've got two more to do, sodium hydrogen carbonate and hydrochloric acid. When doing the products, I see I've got sodium chloride, aqueous. I know it's aqueous from my solubility rules. Another carbonic acid, which is going to further break down again to give me CO2 and liquid water. Still have the sodium chloride, that's aqueous. So those are the products, the final products of this double displacement reaction. That is a gas evolution reaction. Last but not least, let's do sodium sulfite, NaClO4. Doing the same product prediction. I'm going to have NaClO4 and H2SO3, sulfurous acid. And then remembering the rules from the previous video that H2SO3 will further break down to give sulfur dioxide and liquid water. And so looking at those products of this double displacement gas evolution reaction, hopefully you're yelling at me and say, but wait a minute, Mrs. Lapola, we said balanced equation. You took care of the decomposition of the intermediate. Is this a balanced equation? Hopefully you're screaming at me, no, it's not. I've got two sodiums on the left and one on the right. So that means I need to add a great big fat 2 to that side of the equation. Whoops, sorry. I need to add a 2 to that side of the equation, which means I also need to add a 2 in front of here, which I will do like that. So now we have a balanced chemical equation. So for the exam, you should feel comfortable being able to predict double displacement reactions that are precipitation reactions, that are acid-base reactions, and that are also gas evolution reactions. Remembering from the previous rules what those unstable intermediates are, that when those are produced, when they further break down to give you liquid water and the appropriate gas. So that is the end of the double displacement reaction part of this chapter. In the next video, we're going to start to introduce the concept of redox or oxidation reduction reactions.